as part of the ongoing series through the Flutter documentation. Today is the test drive page. This page describes how to create a new Flutter app from templates, run it, and experience hot reload after you make changes to the app. Select your development tool of choice for writing, building, and running Flutter apps. We've chosen Android Studio. Do you want to run your Flutter app on the web? The web version of Flutter is available on the beta channel. Try it out. Check out to write your first Flutter app for the web. Code Lab. We'll do that shortly. For now, we'll open up the IDE and select Start a New Flutter Project. So when you go into Android Studio in this case, under File, select New. It's not Start a New Flutter Object, it simply says New Flutter Project. We are presented with the dialog window. We select New Application, New Flutter Application. Hit Next. Specify the location. Hit Next. And specify the package name. We've done that. And we're presented with the default sample app being the counter app. They talk about on step 3 when they talk about verifying the Flutter SDK path. We can go under Android Studio, click under File, click Settings. The SDK path will be under Languages and Frameworks, Flutter, and there is the SDK path. In this case, I have it already specified. I'm currently using this version of Flutter under the channel stable. Note, when we want to now try out the web app, we'll have to change this channel to beta. So let's run through this and see what we get. I'm just reading this quickly to see if there's anything relevant. We're going to be going through this. Here's the counter that's presented to us. Flutter offers a fast development cycle with stateful hot reload, the ability to reload the code of a living running app without restarting or losing app state. Make a change to your app source. Tell your IDE or command line tool that you want to hot reload and see the change in your simulator, emulator, or device. So let's do that here. So we open up the main Dart file, change the string. You have pushed the button this many times to you have clicked the button this many times. So let's try that. Note, do not stop your app, let it run. Save your changes, invoke save all, or click hot reload. You will see the string updated almost immediately. So let's do this now. Here we are with the sample. The sample app will go down to the build function. You have clicked that many times. Let's do this first, of course. They want us to run it. I'm going to start up the emulator. I find that you always have to keep the emulator up in the foreground for a time to see if it starts up, or you'll just simply have a black screen. The emulator has been improved in recent months. We're going to start this up, and then we're going to change that value. I want to walk through the code itself, give you appreciation of what's going on there. Profile or release runs important. Do not test the performance of your app with debug or hot reload enabled. Alright, the performance logically is impeded to a degree when debugging. So far you've been running your app in debug mode. Debug mode trades performances for useful developer features such as hot reload and step debugging. It's not unexpected to see slow performance and janky animation in debug mode. Once you are ready to analyze performance or release your app, you'll want to use Flutter's profile or release build modes. For more information, see Flutter's build modes. Important. If you're concerned about the package size of your app, see measuring your app's size. We'll take a look at that as well. Okay, so it's ready. It's opened. We're going to run this. I'm going to run it in debug mode. There we are. It started up. So here is the common sample app that you will be presented every time you create a new project, a new Flutter project. Very simple. You've pushed the button this many times. I've pushed it 5 times. Now, just to quickly demonstrate hot reload, let's go back to the build function. You have clicked Here we go. Now if I click on hot reload, look at that. In an instant, it's been changed. In fact, I didn't even have to click it. I can just simply save it. Pushed. Save. It's back. Let's examine now the code. Quickly take a look through it. We are, by default, it provides us with the material design. There's Cappuccino. And there's material. The main function, we utilize the run app. Quickly take a look at that. Under binding, inflate the given widget and attach it to the screen. Okay. So here's our widget. As it happens, it's a stateless widget. So it's going to represent the root widget of the widget tree. This widget is the root of the application. Stateless widgets simply have you utilize the build function. So we override that. And we return promptly Material App. Notice that that's just one line. What we could have simply done is this. And that's the same thing. Notice I made the change. Nothing. It all stays in active resident memory. So here we are. That one line returns a widget. This one's called the Material App Widget. Take a look at its declaration. Quickly, let's just see what it says here. An application that uses material design. A convenience widget that wraps a number of widgets that are commonly required for material design applications. It builds upon the widget app by adding material design specific functionality, such as animation and grid paper. So both the Cupertino as well as the Material App widgets are based on the widget app. Conceivably, create your own design. So here we are. We have the Material App widget. It's provided the title. This says Flutter Demo Homepage. This says Flutter Demo. So obviously in the homepage state, the title is different. So sure enough, when we pass the homepage state widget, here it is there, the homepage stateful widget, an application that uses material design for the root, the home root, the home property is used. And the home property in this case happens to be a stateful widget called My Home Page, and it has been passed an explicit title. And that's the title we see here. So the Material App widget, this title ironically is inconsequential. Remove that. It's provide a given theme. This is the theme for your application. Try running your application with Flutter Run, and you'll see the application with the blue toolbar. Then, without quitting the app, change the prime swatch below the color green. Then invoke hot reload. Press R in the console where you ran. Oh, look at that, where you ran Flutter Run. Or simply save your changes to the hot reload in the Flutter IDE. Notice that the counter didn't reset back to 0. The application is not restarted. More specifically, the state object is not recreated. Okay, let's try that. Save. So if I save this and go back, look at that, it performed a hot reload and it's suddenly green. That is cool. What's this? This makes the visual density adapt to the platform that you can run the app on. For desktop applications, the controls will be smaller, closer together, more dense than on mobile platforms. So let's continue on through the source code. The home page is supplied to the home parameter. So in other words, the root for the Material App is going to be assigned this stateful widget. And this stateful widget is passed either the key and the title. In this case, we don't provide a key. We're simply providing the title. The widget is the home page for your application. It is stateful, meaning that it has a state object defined below that contains fields that affect how it looks. This class is the configuration for the state. It holds the values, in this case the title, provided by the parent, in this case the app widget, and used by the build method of the state. Fields in a widget subclass are always marked final. Indeed, it's encouraged to keep everything inside a stateful widget as as well as, of course, a stateless widget, immutable, values that are not to change. You'll come to appreciate stateful widgets are rather somewhat empty. Take away the comments, and all you have is this. It's a stateful widget that contains an instant variable, a final instant variable, one that does not change once instantiated, once created, and then we simply override the create state function. This doesn't necessarily have to be this state object particular type. This could have been simply state. Change that. Show that what I mean by that. I save that. I'm going to restart it. It's already been compiled, so it should not take as long. And we will run it again. It'll stop here. And you'll appreciate that the Flutter framework does not exactly want my homepage state. It simply wants a state object. So again, simply providing state. The overridden method create state simply returns. So let's do this. As you can see here is the widget, create state. It simply wants to return state object. So again, I could have just simply provided specified state object. Let's quickly just take a look at this function. Read on what this says. Creates the mutable state for this widget at a given location in the tree. Subclasses should override this method to return a newly created instance of their associated state subclass. So essentially, your stateful widgets will contain this. Again, I would suggest you don't need to bother specifying the type of state object. Simply return state. The framework can call this method multiple times over the lifetime of a stateful widget. Yes, indeed. For example, if the widget is inserted into the tree in multiple locations, the framework will create a separate state object for each location. Similarly, if the widget is removed from the tree and later inserted in the tree again, the framework will call create state again to create a fresh state object, simplifying this life cycle of state objects. So let's continue this now. Create state. We'll walk through the framework one day, but for now, let's present this example. We have it at green. It's called the state object. The state object is instantiated. This class is instantiated. It extends the state object state with a particular stateful type of my home page. That's critical because you want to reference properties unique to that stateful widget. So you have to specify my home page. This actually extends a stateful widget, a T of stateful widget. Here we go. As you can readily see, the state object itself, the state class, is an abstract class. You have to fill it in. Whatever type that may be, it has to extend stateful widget. Here allows you to access that widget using a getter. Let's just quickly read the first few lines here. The logic internal state of a stateful widget. State is information that, one, can be read synchronously when the widget is built, and 2, might change during the lifetime of the widget. It is the responsibility of the widget implementer to ensure that the state is promptly notified when such state changes using setState. What we're conveying here, of course, is Flutter's state management mechanism. Let's just read this last paragraph. setStateObjects is created by the framework by calling the statefulWidget createState method when inflating a statefulWidget to insert it into the tree. Because of a given statefulWidget instant can be inflated multiple times. For example, the widget is incorporated into the tree in multiple places at once. There might be more than one state object associated with the given stateful instance. Similarly, if a stateful widget is removed from the tree and later inserted in the tree again, the framework will call statefulWidget createState again to create a fresh state object, simplifying the life cycle of state objects. In this particular class that extends the state object, we have an instant variable called counter. As you can notice here, I could change this now to simply counter. Let's do that. Why? Because it's already hidden. The class itself is named with the underscore, making it library private, making that class only visible, its scope only within this file, counterapp.dart, this library, as they call it. So what do we have here? Again, you really don't need to have that underscore there as well. Get rid of that one. Oops. Undo. It's already retained in here. By definition, you cannot reference this outside this file. In fact, we'll later find out you don't really need this method at all. So, what does this method do? It has the setState function. That's that function used to notify the state object that something has changed. What it essentially does, of course, this function triggers calling this build function again. When it first starts up, this build function is called, creating what we see here. When we make a change, in this case we're going to make a change to the counter value, we want to invoke this build function again, displaying what's been changed. This call to the setState tells the Flutter framework that something has changed in this state, which causes it to rerun the build method below so that the display can reflect the updated values, in this case the counter. If we change the counter without calling setState, then the build method would not be called again, and so nothing would appear. Well, you know what I'm going to do there then. I'm going to prevent this. If I did this, comment out the setState, right? It's going to call, when I press on that plus sign button in the lower right hand corner, it's going to call that function and nothing's going to happen. So I'm going to save that. Hot reload is going to invoke. Look at me. Just pressing that like mad. Pressing like that like mad. I'll prove it. I'll put a breakpoint there. Oh. Nothing. What's the counter value right now? In this method, in this class, the counter is at 12. Uh-oh. So what if I do this now? Go back. Return this this function. Save. Now we're going to hit this button. Oh. I'm going to hit this button and see if it turns into 13. 14. Got ahead of myself. So this is the mechanism for refreshing your screen in Flutter. Quick peek. See that? We pass a void callback function. This definition here describes simply a function, returns nothing. So you have to supply a function that returns nothing to the setState function. It makes certain, while in development, it asserts that that function can't be null. You get an error otherwise in development. It inserts that we are in the state lifecycle. I'll have to look and see what that means. Okay, so set state called after dispose. So in other words, it has to be in its proper state. No longer appears to be in the widget tree. So it does a number of things, but more particularly, I wanted to see here. Okay, so this is where it finally, this is how it calls that function. It also checks the result in development. Make sure that if it's a future object, you're going to get an error, a complaint. That would, dealing with future objects, an asynchronous operation within a synchronous process could cause errors. SetState callback argument returned a future. The SetState method on this was called with a closure or a method that returned a future. Maybe it is marked as async. Instead of performing asynchronous work inside a call to setState, first execute the work without updating the widget state, and then synchronously update the state inside a call with setState. Okay. It needs to be rebuilt. So it marks it as dirty. Marks the element as dirty and adds it to the global list of widgets to be rebuilt. So that's how they actually setState causes the the state object to be, quote, dirty. Hence, the next cycle, its build function is called. This is not a future. It's simply a counter. It's incremented. SetState. Widget is marked, the class state object, I should say, is marked dirty, so its build function will be called soon after. So if I click here, put a breakpoint, hit this, the counter will be incremented. We'll continue, and then it'll stop here because the build will be called again. Sure enough. The build, this method is rerun every time setState is called, for instance as done by the increment counter method above. The Flutter framework has been optimized to make rerunning build methods fast, so that you can just rebuild anything that needs updated rather than having to individually change instances of widgets. So what's inside this method? It's a scaffold widget. The scaffold widget provides the look and feel of the material design pattern. So we have an app bar. That's the app bar up here. We have the body. No, that's not required. Okay. Provide an app bar, which provides the title. here we take the value from the home page object that was created by the app build method and use it to set our app bar title. Widget is there. It's a getter. We know that in the state object, in the class abstract class state. It provides a particular type. We specify that type. Back up here. My home page. We know that the home page, my home page stateful widget has a property, an instance variable of title. So when we go back here, this will work. Widget. That is a reference to the home page stateful widget. It has a property called title. We present that title, we present that string. We know it's of type string. To the text. Take a peek in there. As you can see, you're going to come to appreciate that Flutter widgets have a lot of parameters. We'll get to that, of course. A run of text with a single style. The text widget displays a string of text with a single style. The string might break across multiple lines or might all be displayed on the same line, depending on the layout constraints. So you can specify all sorts of styles and how you present that piece of text. So the Scaffold widget supplies an app bar. It's optional, of course. You can optionally supply the body. In this case, the Scaffold also wants you to supply, if you wish, in this case, it's optional, a floating action button. So the body parameter has been passed the center widget. Center is a layout widget. It takes a single child and positions it in the middle of the parent. So it's taken a child where is it now? Okay, const child. I wanted to see if this was a widget that centers its child within itself. This widget will be as big as possible if its dimensions are constrained and the width factor and the height factor are null. If a dimension is unconstrained and the corresponding size factor is null, then the widget will match its child size to that dimension. If the size factor is non-null, then the corresponding dimension of this widget will be the product of the child's dimension and the size factor. For example, if the width factor is 2.0, then the width of this widget will always be twice the child's width. The widget centers the child. So if this is the child right here, as it happens, it's a column widget. The column is also a layout widget. It takes a list of children and arranges them vertically. By default, it sizes itself to fit its children horizontally and tries to be as tall as its parent. So we know the parent's going to be the size of the screen, and we know the column is going to be the size of the parent, which is going to be the center, which is going to be the size of the screen. So it's all going to be the size of the screen. Invoke debug painting, press P on the console, choose the toggle debug paint action from the Flutter inspector in Android Studio or in the toggle debug paint command in Visual to see the framework of each widget. Invoke the debug paint. Toggle. we'll look at that another day. Column has the various properties to control how it sizes itself and how it positions its children. Here we use the main axis alignment to center the children vertically. The main axis here is the vertical axis because columns are vertical. The cross axis would be horizontal. That would be a row widget. Quickly look here. It extends flex. In this case, its direction is vertical, up and down. So I suppose what we just said is going to be found here. A widget that displays its children in a vertical array. To cause a child to expand to fill the available vertical space, wrap the child in the expanded widget. The column widget does not scroll, and in general it is considered an error to have more children in the column than will fit in the available room. If you have a line of widgets and want them to be able to scroll, if there is insufficient room, consider using a list view. For a horizontal variant, see row. And look at the row. It too extends flex, but as it happens, its direction is horizontal. So the main alignment is centered. The children specified in this case are two text widgets. One, of course, is you have pushed the button that many times. Again, for clicks, we'll say that. The text, counter, and a style. We specified the style. It grabs the style from the build context. Oh, so it grabs the first theme, the theme data object. That counters up the tree. But for now, let's just save that. It's reloading. Pushed. Here we are in the column. Again, I wish I got that inspector working. We can readily see that. That column here has two objects in the center, two widgets. There are two text widgets, one after the other. This returns. Let's change the style a little bit, shall we? Extremely large text. Let's do that. Boom. Headline from headline 4 to headline 1. Reload. Oh. Neglected to turn off the breakpoints. There we go. Okay, so that's why the inspector wasn't working. Turn that off. Toggle that. Oh yes, perfect. So there we are. So we can see there's the column. There's its two elements right there. So in time we'll get acquainted with how that all works. Turn that off. And we're back to here. So what have we done there? I went and changed. Let's go to the build. I changed it from 4 to 1. Let's go back to 4. Save it. And we're right back where we started. The floating action button, of course, accepts the widget. You notice now it just simply says type widget. Conceivably then, you can put any widget you like there. It doesn't necessarily have to be the floating action button. The floating action button Material design, floating action button. A floating action button is a circular icon button that hovers over content to mode, a primary action in the application. Floating action buttons are most commonly used in the Scaffold floating action field. Floating action button field. Here we are. On pressed. As I said, it simply takes in a function that doesn't return any value. It's void. Okay. So let's go back here. See that? I don't want to do that. I don't like that function. I'm going to do this. Grab this. Go like that. Take the body of this function. Delete it. Done. Same thing. This will... Now I've simply passed an anonymous function. Didn't declare one. This is perfectly legal as well. Save that. Boom. So, set state. We're in the set the state object. It's invoked that function. Happens to be anonymous, of course. So when we pressed on press, this anonymous function calls this function, set state. Set state in turn calls its passed function, which happens to be anonymous. See that in blue. And it contains counter. And then that's implemented. Perfect. So, let's read on here. Let's look at tooltip. So, that means if I hover over this, I should get a tooltip. Should I not? Where is it? Oh, there it is. So I hold it down and press it. Tooltip. Text that describes the action that will occur when the button is pressed. This text is displayed when the user long presses the button and is used for accessibility. Child. So in other words, this is just another widget, isn't it? I could necessarily, it doesn't necessarily have to be an icon. Let's right click on here and change that icon, by the way. Let's change it to whatever we like. Something that catches my eye. An umbrella. I'm changing it to an umbrella. So, there. Hit save. There's our little umbrella. So there we are. We've gone through the test drive web page. The next video we'll take a look at how to run this very same program on the web.